correct one? Is it line A or is it line M? Nope, XY. Did I put MY on there? Yeah. Oh, MY is the same thing as XY. Same thing. Yeah, Grace. It is line A. So the answer to B is line, that's not a line, line A. Because if we do those two things, we're going to see they intersect along this red line. And we know that things don't just stop and start with lines and planes, so it has to continue on. So it'd be that whole thing. All right, in the intersection of YX and line A, yeah, that would be point M. Two lines intersect at a point, and that point is point M. Any questions on the bell work? All right, then let's answer any questions we have on the homework. Let me grab mine real quick. I kind of have pre-calc still out for some reason. Do we want to learn pre-calc? We're just doing radians. Okay, questions on the homework. I got it now. Yeah, go ahead.
For number 28, I got the wrong answer and I don't know why.
On 28, suppose a line is known to be in a vertical plane. Does the line have to be vertical? That was the question, right? So if we picture a vertical plane, in fact, I'm going to take a picture straight from that problem. They didn't copy very well, but they're okay. So these are known as vertical planes. Picture this as a wall. Now, it feels like all the lines should go vertical, right? But let me just draw a picture on here. Is that line on that plane?
Yeah.
Is it vertical?
No.
No. So that's why that answer has to be no, because picture this wall. Can I draw a straight line that's left and right on that wall? Yes. I can draw vertical. I can draw a diagonal. I can't draw anything that comes out from the wall, but I can draw anything I want flat on that wall. So that's why that one is no. Other questions? You gots to have them. Gots to ask them. Irfan? Yeah.
Oh, I don't understand about like how triangles and planes connect.
Well, triangles are technically, but we always make them four-sided. It's kind of like, so if you see that plane I have up there, if I draw a triangle on it, is that triangle on that plane? Yes. So you could theoretically draw a plane by drawing a triangle, as long as you know that it extends in all directions. Typically, we draw them as rectangles because it's easier to picture a rectangle going in all directions.
So the triangle by itself.
It is a plane, yes.
I don't get that.
But we use a rectangle to represent it. So I can draw 3 points. And technically that constitutes a plane. Because to be a plane, you just have to have 3 points that are not collinear. What we typically do is we draw a box around it to make it easier to see that plane. So 3 dots could be a plane as long as you picture it extending everywhere. It's just easier to draw a box around it, so we just stick with a rectangle represents a plane. But if I asked you, is this triangle, if I tell you a triangle is a plane, it is a plane. It goes in all directions. Okay? All right, so it's just the symbology of it all. Okay? Is that a little clearer? Okay. You never have to draw a triangle. So if someone gave you 3 points, so if I give you 3 points and I said draw a plane through these 3 points, you could just connect them like that. Or you could connect them as a triangle. Because typically we use 4-sided figure, but a triangle can be a plane. Is that clear? Or? Okay, good. Other questions about stuff we just didn't get or something? Then we're going to do today's lesson. Today's lesson starts with line segments. Yesterday we talked about lines, and that's what we're going to start with on the first thing. If I want to tell you about line AR, what I do is I put AR, and I actually put a line above it. So I put a line above, and that stands for line AR. Now, as a reminder, there's lots of ways to write line AR and it'd be the exact same. If I said, where's line RA, you're going to say, well, that's the exact same line. In fact, I said, if you have a line, you can pick any two letters you want out of there, and that's your line. It doesn't matter which ones you pick because the line goes on forever. So let's say I pick BR. Let's say I pick BR. And you tell me that's not the same as line AR. Well, I'm going to remind you that, well, BR is this, but it continues forever. So is it the same length as AR? Yes, because it goes on forever. No matter which ones of these pick, I still have to go forever up and down. So BR could be one. We can pick NA. That's one. Basically, you take any two letters that are on the line, and that's the same line. Just a reminder, it contains all the points between A and R, everything after R, everything before A, and it also includes the A and the R. If I look at the points B and R, how many points are between B and R?
0.
Is it bigger than 6? How many you got? It's an infinite. It's infinite. Yeah, it looks like there is. And that's why I keep asking that question, Augie, because it doesn't look like there's any points, but there's an infinite number. Remember, if we zoom way in, you're going to see a lot of little dots in there. Just like when you zoom in on a TV, if you get really close to your TV at home, I don't suggest it, but you're going to see those little pixels that are in there. Same thing with a line. If you could zoom infinitely, you'd see little dots. All right, the next thing we're going to talk about is a segment. Now, let's say I give you a line and I just want a part of that line. That's called a segment. It's a part of a line. It starts and it ends. A line goes on forever. So let's say I just want the points between A and R, including A and R. You're just going to write AR, and you're going to look, it's going to look like the same thing as a line, but we're not going to put arrows on it. So if I tell you to picture segment AR, everything before A and everything after R is gone. So what you're picturing is you're going to picture this. And there's going to be times where I draw an entire line and I tell you focus on segment BR, where you have to forget about everything else. And so if I ask you, I give you segment BR, is N on segment BR? No, because segment starts and ends. Yeah, Grace.
So would segment AR include points N and B?
It would include points N and B, yes. And that's why I brought up the fact that if I talked about segment BR, would that include N and A? No. Would line BR include the points A and N? Once again, would line BR include N and A? It actually would, because a line goes forever. A segment ends, and a line goes forever. So be careful on those questions on, like, the test will have questions like that, where I give you a line and I ask you, does this segment contain? You have to be very careful what's a segment and what's a line. I also want to point out this is not the same as just picking any two letters from the line. So segment AR is not the same as segment BR. Because picture what BR would be. BR would just be that little line that goes from B to R. It would not be the same as NB. It would not be the same as NR. The only other way to describe segment AR is to reverse the letters and call it RA. It is the only other way to name a segment is, because a segment has both start and end points. There's no lines, so the only way you can fix it is by flipping those letters. Questions on segments. My advice to you is as soon as I give you a segment, in your head or cover up the stuff, the arrows, so you can easier answer those questions. All right, the last thing is distance. You know how I've been drawing those lines above it? Let's say you get to the homework and all of a sudden you see something that looks like that. Notice I have nothing written above it. If you have nothing written above it, it means I'm asking for a distance. Distance is a measurement, so you're talking like 3 inches, 5 centimeters. I'm actually looking the distance from A to R. So that is the distance from A to R. It will be the same distance as R to distances. Let's see if this makes sense. If this is 1.2 centimeters and this is 1.9 centimeters, what's the total distance between the two? Really think about it. This is going to be tricky stuff. Got this side handling it. You guys just going to let this side handle it? All right, we'll let this side of the room handle it. What do you got? So what did you do? You added them? Mind-blowing stuff, right? That's all this says, is if you have a point down here, the distance from here to the point, from here to the end point, you just got to add those distances. That's what that fancy section is of your notes. So if I need the whole distance, this is the mathematical way to put it. If I ask you what's the length of EF, remember, length is if you don't put anything above it, that's just going to be the small segment plus the other small segment, which in this case would be 1.2 centimeters plus 1.9 centimeters, which does equal 3.1 centimeters. Earth-shattering stuff today. Really shake you to the core. The next one doesn't have you adding anything. What do I do? Do I quit? I'm not sure what I do. Brooke will let this side handle this one.
We're gonna have subtract 2.75 from 6.
We're going to subtract the small one from, and it will be left with the other one. In other words, here's kind of a long way to do it, I guess. These are your notes, so I'm just kind of showing you. So we know that AC equals AB plus BC, right? Long equals short plus short. Well, we're allowed to move stuff in equations as long as you subtract it from both sides. So we can also do something like, we're looking for BC, so if I want that on the same side, we can go something like BC equals AC minus AB, which in this case would be 6 minus 2.75, and unless I can't do math, that should be 3.25 inches. And my assumption is anytime we throw x's in it, you just quit and just move on to the next problem, right? Seems like the easy way to do it. All right. I said we're moving on to the next one. It's too hard. Can you do it? Oh, okay. Then we'll try it. If you're going to try it, I guess I'll try it. What do you got?
Are you supposed to try it?
Yeah. Just tell me how did I start looking for x? How did I start a problem like this?
Well, 2x plus 5 is supposed to equal x plus 2x.
Yeah.
So, and 2x plus x is 3x. So it's 3x equals 2x plus 5. So subtract 2x from both sides.
And boom, you have
X equals 5.
x equals 5. That is 100% perfect. So we know that that total length, that 2x plus 5, 2x plus 5 must equal the two little parts. That's x plus 2x, which you already did all the math for me if I remember right, that this would equal 3x. And then you described perfectly that we need to subtract 2x from both sides because we can do whatever we want as long as we do it to both sides and everything stays balanced. Boom. And we're left with 5 equals x. A better way to write that is just x equals 5. You'll notice in this class, I don't know if you guys did this in algebra, a lot of times I'll just circle this because it is the answer. 5 equals x is the same thing as x equals 5. So a lot of times I'll just circle and say, I'm done. You figure out how to flip that around. All right, that's distances. Now we're going to do something called congruency, congruent segments. Congruent segments need to have the same shape and size. Well, it turns out they're segments. They must have the same shape. Every segment is a segment. I'm not going to compare segments to triangles. So we're already comparing two segments. So we're really looking for the same size. Are they the same length? So congruency is same kind of length of our line. Now, I do want to point out something really quick. What is the symbol for congruency? Well, equal sign, we already know that. equal is that sign. Congruent, you just put a little tilde or a little squiggly mark over it. That's going to stand for congruent. Anyone want to take a guess at the symbol for not congruent? It's like congruent, but it's like not congruent. Like you're like, hey, it's not congruent. What do we usually use for not?
Is there just like a line through it?
There's just a line through it. Just one line. Don't go crazy about it. You don't need it to circle. It's just that, and that is not congruent. We do the same thing with equal. So if I was describing this to someone, I would say, you know what? DE, and I would put segment DE is congruent to segment FG. Now here's the semantics of a congruent symbol. Congruent means it's the same shape and same size. So we can't use equal signs. Lines don't equal each other. If they're equal to each other, they'd be the same line. They're not the same line. They're different lines. They just happen to be the same length. That's what congruency is. However, measurements can be the same. Because what's the measure of one? 3. What's the measure of the other? 3. So if you're ever using a notation that includes measurements, so I'm going to put a little note down here because it's not really part of this, but I'm going to note that if I don't put lines above it, I have to use an equal to sign. So that is, remember, this is measure. The measure of this one's 3. You're basically writing 3 equals 3. This is this measure equals this measure. This is telling you a segment is congruent to another segment. Yes?
So the shape of the segment is the same.
Right, yes. Just like when we're going to compare triangles, so we'll say triangle, something is congruent to triangle. We're never going to compare something, but the term congruent means that we're dealing with the same shape and size. So if one's a segment, the other one has to be a segment. All right, then we're going to put a little more notes on here. I'm going to put a little wall. So this is how you do it notationally. But sometimes you want to show things are congruent within a picture. So to show things are congruent within a picture, so let's say I have these two lines. And I want to say they're congruent without actually writing out that they're congruent. What we're going to use are tick marks. You're just going to put one tick mark here and that tick mark there. Now, anything on that drawing that has tick marks are going to be congruent. So you might have like 8 lines that are congruent to each other. It might be a big picture, and you got to find all the tick marks that match up. So we're going to use something called tick marks to show congruency. And you're going to see a lot of those in our class. Okay, let's pretend I'm on the same drawing. Let's say I'm on the same drawing and there's 2 other lines that are also congruent. So I have 2 other lines down here and I know they're congruent. Now, I put tick marks on those. Here is the problem. It's in the same box, right? I have it in the same spot. So if someone's reading this, that must mean that all 4 of these are congruent. Do all 4 of those look congruent? No, but if I put tick marks on it, they have to be. So it doesn't make sense if I put tick marks on all of those. But I still want to tell the reader that these are congruent and these are congruent. So all you have to do is add an additional tick mark. So 2 tick marks means there's 2 different things that are congruent. These 2 are congruent and these 2 are congruent, but they're not congruent to each other. You're not going to believe what happens if you have 3 sets of them. You have to put 3 tick marks. And then 4, and then 5, and then 6. You don't really get to 6. Usually it's just 1, 2, maybe 3. All right, those are tick marks if you were looking at a drawing. Next thing we're going to talk a little bit more about is distance between 2 points. Now, distance has to be positive. First and foremost, distance is always positive. I did that with Brooke. That I don't measure from you, it's -4, and from me, it's +4. So that means whatever distance we have, it has to be positive. So it makes sense that our formula has absolute value bars because last time I checked, absolute value is distance from 0. So, yeah.
Me and enough to go.
Yeah. Oh, yeah. Get out of here. Good luck, guys. So This formula has absolute value bars because absolute value makes it positive. The nice thing about absolute value bars is that means that you can put any point in any order you want. So this says, if I want to get the distance between A and B, I just get the values of both of them and subtract. And it doesn't matter if you do x1 minus x2 or x2 minus x1. And yeah, I know on this drawing it's probably easier just to count it. But what happens on the test if I say x is 132 and y is negative 250, and you don't want to have to count all the way through? So let's learn this formula. So distance formula is subtract the 2 and take the absolute value. So if I'm going j to k, it doesn't matter which one I do first. So the distance from j to k is going to be, now I always put parentheses. So it's something minus something. It seems tedious, but it's going to keep you from making those dumb mistakes with negative signs. So it's something minus something. What goes in those somethings are just the numbers below. So j is negative 8. So I'll put a negative 8 in that first parenthesis. K is negative 3. So I put a negative 3 in that parenthesis. Now I'm not messing up positive and negative signs. Now I'm going to realize that, hey, there's no number in front of negative 8, so I can drop those parentheses. So that just equals a negative 8. But what's a negative of a negative? A double negative? A positive. So it's negative 8 plus 3. Note, it's not plus negative 3. These two cancel out and turn into a positive, which is going to give us a negative 5. Absolute value of negative 5 equals 5. Now, in theory, I can flip that negative 8 and 3 and I'll come up with the same answer, right? That's what the formula says. Let's do it. Let's go ahead and flip them. So first of all, I'm going to start with parentheses so I don't mess up my negative signs. This time I'm going to put negative 3 in first and negative 8 in last. That should be negative 3 plus 8, correct? Which would actually equal absolute value of 5, which once again equals 5. Quickly do the next one. If you haven't already, do not. So that one's going to end up being just 4. Positive 4. A couple of us still had negatives. Be careful about that. Okie dokie. Let's talk about a midpoint segment. A midpoint of a segment is a point that divides. What does midpoint sound like to you guys? Like midway, like the middle. So it's a point that divides the segment into two congruent segments, right in the middle. Two congruent segments. So let's put a midpoint on here. So just approximate. I'm going to do a terrible job and I'm going to fix it. Don't make yours terrible like mine. That's my midpoint. Does that look like it's the midpoint? No. I'll tell you why in just a second I'm doing that. All right. But I'm going to tell you it's a midpoint. I'm going to say P is the midpoint. P is the, and I'm going to be lazy and just put M dot P because I'm kind of short on time, is the midpoint of, you should say what it's the midpoint of. A line cannot have a midpoint because it goes on forever in both directions. Only a segment has a midpoint because there's a start and end point that you can measure. So when you're doing, so even if this was a line, let's say it was a line AB, you would still have to say it's segment AB. So you have to combine it to that segment to say it's a midpoint. All right, do we all agree that that is not the midpoint visually wise? I'm about to make it the midpoint, and you can't argue it. What do tick marks mean? They're congruent. In this class, no matter what it looks like, you have to look for symbols before you judge something. So if something looks like 90 degrees, it has to tell you it's 90 degrees to be 90 degrees. In this class, if things look congruent, they have to show you they're congruent. If things don't quite look like it, but it tells you it is, it is. So if I draw a picture and I put those tick marks on it, I don't care how dumb it looks, those are congruent, and P is a midpoint. No matter how poorly I draw it, That automatically makes it a midpoint. What that means to you is when you're on your test, if you're like me and you have sloppy penmanship and stuff, be careful to mark things. Because I don't have to rewrite the P, I can just put tick marks and it's the midpoint. Sorry, Mr. Pabian, I put the tick marks on it. All right, P is the mid, don't do it on purpose. Don't just be a jerk about it, but if it's close and you put tick marks on it, I'm good. All right, P is the midpoint of AB. That means the distance from AP equals the distance to PB. So we could do something like AP, and as long as we put a line above it, we have to use the congruent symbol. If I don't have stuff above it, we say distance is equal. Note I put both different versions. No lines equal lines congruent. All right, I'm going to skip the next part just to make sure we can get through all of our notes. If we have time, we'll go back to it. Because we actually have 2 days to do this lesson. We just have a shorter homework tonight, and we have a longer one tomorrow. All right, bisector of a segment. Well, it follows midpoint. It's a line, segment, ray, or plane that intersects the segment at its midpoint. At its midpoint. So the first thing we're going to see is actually what's called a line bisector. So do we all agree that M is the midpoint? Is it just because it looks like the midpoint? How do I know for sure it's a midpoint? How do I know for sure it's a midpoint? Yeah. I got the tick marks. Is M the midpoint of D and C? No. It doesn't look like it. Even if it looked like it, you don't know unless you have tick marks or something saying it's the midpoint. So we know for a fact that M is the midpoint of AB. So that means that line that cuts through M is a bisector. So we could say something along the lines that line DC bisects line, not a line. Remember, can someone describe to me why I can't do this? I'm going to say it bisects line AB. What rule did I say we can't do that, Augie?
It's a segment, not a line.
It
You
has.
have to have just a line without the arrows on it.
And it has to be a segment to have a midpoint. And so that means it has to be a segment to have a bisector. Even if I had arrows on here, and you will have drawings that look like this. You will have drawings that look just like this. You still have to refine your search to the segment AB. So I can give you a line. You can say, Mr. Pabian, the line's not going to work, but the segment version would. So if I give you this whole line, you're like, well, a line doesn't have a midpoint, but segment AB does. I can just talk about segment AB. I can give you an entire line, but you can talk about just part of it. It's almost like in your head you're erasing those lines. So as soon as I start talking about midpoints in your mind, you can just erase those arrows, even if they exist. All right, we already said that M is not the midpoint of DC, right? So the order in which we say something, so I'm saying DC cuts AB in half. We can't say the opposite direction. This is not, you cannot write this in this case. It is not, so we can't write the other way. We can't say that AB bisects DC. You cannot say that. And I guarantee this is a question that's on the test that messes people up for no huge reason, just that you don't go back and you study it. The direction matters. So it'll be a test that'll be like, true or false, AB bisects DC. And you'll see that word bisect, you're going to see a midpoint, you're going to go, yep, it's true. Make sure the order makes sense. AB is this line. Does AB cut DC in half? No. It gives us that little section and that big section there. So the order matters in which you say bisect. Is that good? Do we have any questions on that? Guarantees a true-false question on the test. Yeah.
So if the point
A great thing to say. So if I would add double tick marks on here, just like that, we can now say it both directions. We can say DC bisects AB, and we can say AB bisects DC because I put those two tick marks on there. And once again, it doesn't matter how it looks. If I put the tick marks on there, it's a midpoint. So I always see what the midpoint is of what line is actually bisecting it. And a lot of times when I'm doing true falses like that, I'll come up with the right answer first and see if it matches. So I'll look at that picture and go, oh, AB bisects DC, then I'll go to the true false question and see what they're asking and see if it matches up. Because sometimes true false tricks us because we're just reading it as, oh, yeah, bisects, those words are right. Get it right first and then look at your true analysis. All right, a plane can also bisect a point. Now, on this drawing, we're trying to picture that this plane is actually traveling along L, so it's actually being forced in there, and this line's cutting through. In order for P to be a midpoint, you know what we need to do? We need to put tick marks on it. So that means P is our midpoint, which means the plane bisects. Help me out here. So I'm going to say plane X bisects which line? Plane X bisects either AB or line L. There's a slight hint in the way I said it too. Maybe. Just raise your hand. Yeah. AB. It's going to be a segment AB. Because this P is the midpoint, we know we're bisecting this line. It should be the last one that's said. So that's that segment AB. Plus line, it can't bisect a line. I don't even have points on a line to make it a segment. We could put some on, but... So we have segment AB. All right, so those are bisectors. Most of the time we don't do plane bisectors. Most of the time it's a line bisector, a segment bisector, a ray bisector. Because planes are hard to draw and make sense of. All right, we got two more things left. We got a ray and we got opposite rays. It's like opposite day, but with rays. A ray. A ray is kind of a combination between a segment and a line. It's like half line, half segment. So we start at an endpoint, which doesn't really make sense, does it? You start at the end. We start at an endpoint, not an endpoint. And it goes in one direction. So my example of a ray will be, it's going to start at A, that will be my endpoint. And then it's going to go forever in another direction. And I'm just going to call a point on there B. That's a ray. It's half line, half segment. Yes?
Does it need a second point?
It does not need a second point, but you typically need one to name it.
Oh, yeah.
Because kind of like a line, you need a second point. You can't really name a ray with a lowercase l because that would be the whole line. So you typically need a second letter to name it, but a ray itself does not need a second. So when naming this, there's only one way to name it, and that is AB. Because look at where the endpoint is. The endpoint's over A. So you're telling the reader that A is your endpoint, and notice the arrow's over B, so the B must be going in the arrow's direction. You can either do it AB. This is the correct way. This is the way I want you to do it. That's the way I want you to do it. Some people switch it up and do it BA. As long as the A is by the endpoint and the B is by the arrow. Typically, we always write it left to right. No matter what, we write it left to right. Any book's going to have it left to right. Any program's going to have it left to right, but there's technically nothing wrong. Here's the thing you can't do. It is not AB with the arrow running the opposite direction. Because once again, is B my endpoint? You're telling me it is. Does A by the arrow? That's what you're telling me it is. So that's why this one is wrong. Do not do that. That's important to remember. All right, opposite rays. We got about 2 minutes to cover opposite rays. They're pretty easy. They're just rays that go in completely opposite directions. So the first thing is, it's going to be on the same line. It's basically 3 points on the same line. It is collinear, so it's going to look like a straight line. they're going to have a common endpoint, and they're going to go in opposite directions. The one that people mess up on is common endpoint. So an example of an opposite ray is basically a line with 3 points on it. Let's call them A, B, C. So we'd say something like, so this will be our common endpoint between our two rays. Notice it's just 1 point that they share. They share an endpoint. Now, what I'm picturing are actually two rays. I have a ray going this direction, and I have a ray going that direction. Is there any overlap between the two rays except for that 1 point? No. So you'll never have opposite rays that share anything besides that 1 point. There'll also always be a straight line. Opposite rays will never look like, ooh, not a really good place, but it'll never make like a V. Those aren't opposite rays. So in this case, we could say something like, and I'm gonna do it the way, so B is an endpoint, so I'm gonna say BA is an let's go BA and BC are opposite rays. I'm going to call it op rays because we're almost done. I do want to point out, notice how my arrow is going different for BA than is up here. But is B my start of this ray? Is B the start of this ray that goes on the left? Let me highlight in red, so I'm talking about this one here. Is B the start of that ray? Yeah. And is A where the arrow goes? Yeah. So as long as you do that, we can go to that left to the right with the arrow. All right. Real quick, as you guys are actually before you pack up. Sorry, I'm going to take up too much better time. Page 9 is your only homework. No. Yeah, page 9 is your only homework.
The entire page 9?
The entire page 9, because if you get to page 10, it says 1.3b. That's tomorrow's homework, okay? So just page 9. That's it. Anyone knows? No one knows any money in this class. Geometry's good. It's pre-calc, those pre-calc students that are always causing trouble.